Well, Alexis, I am glad that you could join me today and get to share some great things with the community regarding data management and infrastructure. So, do you want to kind of give just a quick introduction of yourself and the topic?
Sure. Well, I'm Alexis Perumal, and let's see. My background is in computer science, and I started my career as a software developer at HP in San Diego. Worked in digital imaging and got involved in digital photography and the whole transition into color in the office, going from analog photography, silver halide, into digital imaging, and worked in that space for a long time. And then really from the standpoint of software development, although I also at different points in my career got involved in managing other engineering disciplines like EE and mechanical engineering. And then I made a transition in my career to the life sciences, to Illumina, which is the world leader in DNA sequencing technology. And Illumina was very interested in my background in large-scale software development as the company was growing, and got involved in a lot of different things at Illumina, dealing with large big data sets of DNA sequencing data. And then I left Illumina actually in the middle of COVID and went to an Illumina spinoff called Grail, which works in the cancer detection space, and was actually asked to come in as Grail was growing, and was asked to build out the IT organization at Grail. And so I had a chance to do that, and I've been at Grail ever since, approaching 5 years at Grail. A lot has changed at Grail over that time period. There's been a lot of growth, and then also some challenges as well. And then my role has also evolved at Grail, and I'm now involved leading the DevOps, site reliability, and build engineering organization as well within our software development organization.
That's really cool. That is I mean, there's quite the evolution and diversity of experience. And even just, I was thinking about as you're talking about like introducing color and going from analog to digital in photography. And I was like, well, as we're going to jump into the topic of data, I was like, what we mean when we say data over the span of your career has changed a lot. Like what
That's
that
right.
looks like and what does it manage, and the complexity and the layers and the abstraction and all of it. Really interesting to think about. So I'm excited to kind of dive in. But yeah, if we're talking about data management infrastructure, give us kind of just what are we talking about there? Give maybe just a brief intro to that topic as it relates to entrepreneurs and founders.
Sure. Well, I guess the first thing I would say is there's a lot of different types of data, right? You have obviously your customer data that you probably care a lot about, right? Because I would think most entrepreneurs are very customer market focused. There's also internal data on your internal organization, your business operations. Of course, any entrepreneur is going to be focused on financial data, right? Because that's measuring how the business is doing. You could also think of in terms of like your goals and OKRs. You're going to have what they call KPIs, key performance indicators, and those are varied, but those will be typically quantitative metrics that you use to measure how well you're doing against your goals. So I would say first you should think about the different types of data you have. And then to your point, where does that data come from? Where does it go? How do you use it? And gosh, there's so much to think about there. So first, I would say, starting with the externally focused, I think you need to be very intentional about what is your contract with your customers and what are the expectations. Data can be very sensitive, and so before I would say like one of the very first things you should do in defining your data strategy is to think about what is that agreement that you have with your customers? What is that compact with them? And how do you respect and honor that? For example, at Grail, we're dealing with cancer detection. We've developed a test called Gallery that can detect early stage cancer from a blood test. And one of the scenarios, that we've talked about is, in politics, presidential politics, they talk about an October surprise just before the election. And you could imagine, if the main candidate, if there was data leaked about prevalence of, that they may actually have cancer, or maybe that they don't have cancer, right? Either way. So information about your health is very sensitive. So I would start by understanding what are those boundaries. And I think there is a tension there because I would say there's a tension there because the data can be very powerful and it can be very lucrative to you, right? You have the opportunity to gather analytics on what people are doing. There are opportunities to monetize that yourself. There are also opportunities for you to sell that data to data aggregators that is lucrative to you. And so I would say there's going to be a tension there, and you need to figure that out. And then it depends on the industry, right? Fintech or life sciences, the data is critical to the health of the business. Within the life sciences, of course, in the US, you have HIPAA, you have a lot of regulations around how you manage that data, and you need to be aware of that. GDPR in Europe, CCPA in California, and a lot of states are following that pattern. So you should be aware of those expectations, those requirements, and you should be respecting those. Even, I know the focus today is not cybersecurity. Cybersecurity is a hot topic, but even from the standpoint of cybersecurity, the way I would describe it is that the inner sanctum of what people are trying to get is the data, right? That's what the bad actors are trying to get, is the data. So all of these things about getting access to systems or passwords and authentication or spoofing user accounts, those are actually a means to an end. Those are vectors that they're using to get to the data so that they can get the data themselves and maybe even take it away from you. And so it's maybe a little bit of an oversimplification, but you can almost think of your cybersecurity strategy as what do you need to do to protect your data fundamentally, and then everything layers on top of that. So I would say those are constraints you need to think about, and then from there to consider, like you were saying, like where does this data go? How is it stored? How long is it stored there? What is the data that you're collecting? Even how does your data move? And how does your data move across systems? And how do you ensure it's secure both at rest and in motion? Typically, another thing I would say is that typically, like if I think early in my career, we would be trying to solve a problem, and we would want to get a system to solve a problem. And pretty quickly, we began to realize that the magic is not what the system can do and what you can do in the system. The magic is how the systems stitch together, which actually gets to things like middleware, right? And how the data flows across systems. And then I would also say, analogous to that, the power is not just your data. The power is how does your data connect to other data and stitching that together. So I've said a lot. Maybe I'll stop there, and then we can go in whatever direction you're interested in.
It's good. It's like there's so many paths in there. But I love that you started there for us with like just the kind of the responsibility of stewardship over that data, of both what do I collect, how does it get used, how does it get protected, but then also then there's in a sense the stewardship of how does it get leveraged for good, how does it get used effectively, stored effectively, all of those things. So I really like that in both senses, I really hear you framing it as a stewardship of that data. Because I mean, especially like you're talking about in your spaces, in some of the life sciences, but really in probably most businesses, what we're storing is data about people. And,
Right.
because at the end of the day, whether you're B2B, B2C, whatever, there's some level of human to human, and there's a lot of human related data in there. And so we really do want to steward that well. So, well, let's kind of take that though, and then walk through some of these different stages of growth in our framework. So we leave discovery when we have that validated offer. And then really adoption, there's two kind of in the model, both adoption and scalability are kind of transitional states. So adoption is this transitional state between discovery and sustainability. So sustainability, we kind of know what that is. That's having that established growth, like consistent, stable growth. But adoption is really getting to like that first economic milestone. The way we usually define that with entrepreneurs is say, okay, what's that revenue goal that you need to hit for a year in sustainability? Well, what does that look like in a month? And let's get that month at least one time. And at that point, then the question becomes, okay, how do we make that 1 month that we finally hit the normal month? And that's kind of really the goal of sustainability, is to make that just normal and optimized. But there's kind of going from, I have an idea that or an offer that we've validated, to I have the month that I want to repeat over and over again. And so that's that adoption process. We're really getting market adoption in order to reach that milestone. So in that stage, that's where, we're doing a lot more engaging and with customers. So how does some of maybe the questions change a little bit, or pivot in related to data in this adoption stage?
Yeah, so that makes me think of, well, I don't know if I mentioned, but my background, part of my background is I went to Wharton and did the MBA program there. And one of my observations, I did 2 different majors there. I did finance, and I also did marketing and operations, which was a joint major. So I did marketing and operations was one major, finance was the other. And it was a fantastic program. And of course, Wharton is known for finance, which is part of the reason I did finance, because I was like, when in Rome, right? And the finance courses were very quantitative, as you can imagine. Got into portfolio theory and options and valuations, all kinds of things. But it was actually the marketing courses that were actually the most quantitative and the hardest courses at Wharton.
Interesting.
And surprising, right? Because most people think of marketing as fluff.
Right.
And if I tell you the finance courses were quantitative and hard, you go, of course, right? But you think of marketing as fluff. But the whole marketing department at Wharton is all made up of these MIT PhD statisticians, and it's very quantitative. It's extremely quantitative, the way they approach marketing. And of course, this is supercharged in modern times because everything is over the internet, everything's over the web, and all of that is quantitative intrinsically. It was much harder for marketers in the 40s and 50s and 60s when, like, for example, impressions on a billboard on the highway, you could maybe calculate how many cars drive by that billboard. You don't know how many people actually look at the billboard, right? Whereas impressions in a web browser with an ad is easier to measure. And so fundamentally, a big part of what they're trying to understand is, how do you optimize customer acquisition? How do you optimize your customer acquisition spend? And it really gets to customer lifetime value. And so there's been a lot of interesting work done by Eric Bradlow and his group there, where they look at that optimization of your customer acquisition budget, and how do you find those customers. And it fundamentally is around this basic principle that I talked about, which is understanding the key attributes of your most valuable customers, and then finding more customers that are like them in the key attributes. There may be a lot of attributes that you can collect that actually don't matter, And then there's
Right.
other attributes that matter a lot, right? And so part of that is collecting that. And obvious things would be age, gender, annual income, zip code, those kinds of things. But also, you see like Amazon and Netflix look at, affinity with your buying patterns and all those kinds of things.
Totally.
But I would say the way the opportunity in analytics is to get that adoption, and we touched on this a little bit earlier, is to understand the signature of those customers that are your most valuable customers. And value is not just measured from what they've done, but it's also what you expect them to do. Over like customer lifetime value is a net present value
Have a less churn, have more of an upsell rate there. Yeah, totally.
over time.
No, I like that. I like how you're talking about like what's that signature, because it's like cool, we had 100 new customers, but then it's like recognizing like, well, is there something true about that batch that lets me, when I run ads later again, that I'm not spending for all these extra people that share some attributes, but again, not the right ones,
Right. And you have customers that you actually make a lot of money. They have a very high customer lifetime value, and that's a net value, right? Of what is the net value to you? And then you have those that not as high, but you still have a positive lifetime value. And then you have a bunch of customers where it's negative, right? So it can be as important to not just attract the right ones, but to not attract the wrong ones.
Yeah. The ones that burn endless numbers of support hours and things like that. Yeah, no, totally. That's a really good call out there. But especially I think for someone in that adoption stage, because they're trying to get to that first kind of that first taste of sustainability. And, it's common kind of approach is like, hey, all customers are good customers. If they want to give me money, great, come on in. But you can still have ones where it's like, hey, this customer is slowing you down from reaching more of the ones who are really going to take you where you want to go. And so it's not always easy to discern that, but yeah, if there's different attributes that you can start to recognize, and some of it, like you've kind of said before, I imagine people would start to feel intuitively, but again, it's really helpful, I imagine, to have that data, because the business is right here, it's right in front of your face, and it's hard sometimes to step out, and that data can help initiate perspective, I imagine.
Well, and it may be that there are some of these early customers that maybe later on you wouldn't have wanted, but they were there, and you needed customers, and they were there, and so that may be okay. But I think it doesn't mean you fire them as your customers, but it may mean, if you have this level of self-awareness, that you realize that, okay, that made sense at a particular time and place, and I'm going to grandfather them in, but I'm not going to continue to look for more customers like that.
Right. No, that's a good way to frame that. I like it. That's good. Anything else you want to name for that adoption stage, that as someone's really trying to grow that customer base and that revenue coming in? Is there any other questions about data, or maybe resources, things that they should be, and that resources could be like things they need to be learning, but it also could be, hey, these are the types of people you need to start surrounding yourself with, whether that's adding to their team or consulting with, like what's kind of some of the expertise maybe that they need to start engaging with, because some of this may be natural to them depending on their background, but it may also not be.
Yeah, no, that's a good question. So the conversation we've had so far has been more externally focused, right? Looking at the market and the customers. We haven't talked very much about what that looks like in the back office operationally within the organization, right? And so to your point, initially low overhead, you need to be scrappy, but then as I think of like Jeffrey Moore crossing the chasm and then inside the tornado, right? As you're scaling up the business, and I think we'll probably get to scale next, right? You need to a key part is how you do that. How do you set yourself up for success going forward? How do you do that in a way that's lean and efficient? What do you prioritize? What do you hold off? What is the type of expertise you bring in? What are the types of systems you bring in? And then also how do you optimize internally, right? So part of profitability, right, is revenue. The other part of it is cost. I would think at this early stage where you're focused on adoption, you're not yet at that optimization stage where you're trying to tune your offerings and your operations to be as low cost per unit volume. It's really more just overall cost, right? Because you have a burn rate. But even there, I think you want to think about what are the key parameters of your cost, and how are you monitoring that. So this gets to the whole set of internal metrics and internal analytics that you're doing and that you're measuring.
Yeah, no, that's really good. And let's go ahead and just jump into sustainability, because we're already kind of starting to touch on it a little bit as we kind of wrap up here. A couple of just more fun questions in here. What is Alexis? What's a favorite AI tool that you got?
Well, I think the best AI tool is your brain.
Okay.
Right.
Okay, that's a new answer. I have not gotten that one from anyone. I like it though.
Yeah, I think and to think critically about these things. And I mean, honestly, I've just been using Gemini and integrating it into my life. I have enterprise chat GPT at work, and I have Gemini personally. And so I go back and forth between the two of them, and it's interesting to compare them. Honestly, I'm using Gemini in many ways as a substitute for Google search in many ways. And that's where I think Gemini actually does a little bit better than ChatGPT is with maybe more recent data. But to me, what's happening with LLMs right now is amazing because, well, I guess the way I would describe it is just taking a step back. I think of atoms and bits, right? Okay. And so if you think of the traditional economy, it's dealing with atoms. General Motors builds a car, right? You have products. You go to Costco, you buy stuff, right? These are atoms, right? And then the digital economy is about bits, right? Google, Netflix, right? These are all about bits. And in computer science, software is all about bits. Software is much harder to deal with atoms. It's easy to deal with bits. In large volumes of bits we can deal with. And so there's been a lot of work over the past few decades, right, to digitize everything. Why? Because it's like this high-speed superhighway. If you can digitize the information, we can process it and we can do things with it incredibly fast. If you're dealing with atoms, it's hard.
So the constraints are more readily apparent.
Everything is orders of magnitude slower, right? And like, for example, in the backyard, you want to play soccer, you need a soccer ball, right? If I want to make 100 soccer balls, is it easy to do that in software with a digital soccer ball? Like, if I can build one soccer ball in software, then I can create a for loop and I can make 100
many as we want.
100 million. It's easy. If you want to make 100 million soccer balls, you're going to make factories all over Pakistan, right, to do that, right? So there's been a lot of work to digitize the world, and even like actually, like, I live in San Francisco with Waymo, right? Huge amount of effort. I mean, if you want to make a car drive in a computer game, easy. You want to make a car drive in physical city streets, that's hard. Right? Those are the atoms, right? And this is the intersection of the atoms and the bits. And so Google is very powerful in this world of bits, much harder in the world of atoms. So all this work then goes into driverless cars, trying to figure out how you can apply the world of bits to the world of atoms, because if you can figure that out, then you have huge efficiencies, right? And so I guess the way I would think about it is, computers from the very beginning deal with numbers. They can do math, they can do computation, and they can do it much faster than humans. And we've seen, decades of development. But language has been much harder, right?
Right.
And but then what we see now with LLMs is you're able to vectorize language, and you're able now to bring language. I talked about atoms a bit. Now you're able to bring language into the realm of math.
Yeah, which is wild.
And math is something that computers know how to do really well. So it's an exciting time, and I think where this goes is not clear, right? I mean, there's a lot of speculation, but I think it is very profound, and what this looks like, only time will tell. But I think it also creates a lot of opportunity.
No, I think it definitely does. Yeah, it will be exciting to see. Yeah, it's exciting, and then sometimes scary, where it's like, this feels like one of those, dystopian movies that I watched recently. When you see some things. But well, okay, well, what we talked about a little bit, yeah, AI.
And actually, let me make one other comment too, if I may, and that is that like, I think of it as like AI fundamentally, like what is AI? Because I remember, like, decades ago when I was studying computer science, we had AI, and I took AI classes, and it was an interesting curiosity, but it wasn't dramatic. It's now becoming dramatic. It's becoming dramatic, right? And what changed? Why is it dramatic? Like, what changed between then and now? I would say, well, it's so you have, I think, three elements that go into it, right? One is the data. Second is the compute.
Yeah, just the power of it.
And third are the algorithms, right? So what's happened with data? If I compared to like where we were decades ago, well, there's a lot more of it, right? And it's what we were just saying, how everything is getting digitized, right? So I go do a workout, right? I have my heart rate monitor. I have all this digital data that's streaming into the cloud with my health, right? So a lot of health data, just as an example, right? Your house, right? You have temperature data. You can have temperature data from different parts of the house. You can have it all the time, right? I talked about the COVID data that we were able to get in real time during COVID. At least daily case counts from every county in the United States or every country, right? So you have this explosion in data. What has happened with compute? Well, it's Moore's law. Compute has gotten much more powerful, right? By orders of magnitude, both with CPUs and GPUs. And so, and then what has happened with algorithms? Well, there have been breakthroughs in algorithms, particularly with LLMs, and some of it is enabled by these other things. One of the things that's interesting with LLMs is that they realize that, often in life, you hit diminishing returns to scale, right? Where you do something, you see benefit. You do more of it, you see benefit. You see rapid benefit. But then if you keep going, you hit diminishing returns. But what they found with LLMs is that as your model size hits certain sizes, you hit a knee in the curve, where all of a sudden, instead of just garbage, it actually makes sense. It's actually doing something coherent, right? And so, and it's hitting these knees at points that the amount of data and the compute power that we had 10 years ago was not sufficient. And then these algorithms now are taking advantage of that, right?
Right. Yeah. You get that critical mass in there.
Get that critical mass. And so I think that's where we are. And again, where that goes, I think we'll have to see. There's a lot of opportunity, there's a lot of threat, there's a lot of fear, there's a lot of excitement, and all of that is appropriate. But in some ways, though, I think it's following historical patterns. And I'm a big fan of history, and if you look at new innovations, the Industrial Revolution, computing itself, right, as these innovations came online and the impact they had on society and the concerns that people had with it at the time. Like I remember, I remember when I was in 8th grade, we would open up the math textbook and they would have us go to the appendix, and they would have tables in the appendix for things like logarithms or sine functions, or even, I don't know if they had square roots, but they would have these tables in there.
And your calculator didn't do it. you know.
Well, they would teach us how to interpolate. Now, we had calculators when I was in junior high, but
like graphing, could they do those, like the logarithmic stuff, or anyway?
Yeah, I mean, they could do those functions, but the tables were still in the textbooks because the textbooks were from like 10 years ago.
Right.
And,
okay.
and, and it was still in the curriculum a little bit because the curriculum was from like maybe 5 years ago or something like that. So every once in a while they would say, okay, well, this is how we would do it, and you would interpolate between these values, right? But you don't have to worry about that. Just hit the button on the calculator, right? There was this idea that, well, calculators are going to destroy education because nobody's going to learn any math because the calculator will do it for you. So these kids are going to be stupid, right? Well, they're not stupid, right? And then you could say the same thing about Excel and these tools that came on, right? So, so a lot of this, so I'm curious to see how it develops, but like this idea that LLMs are going to destroy education because nobody will ever know how to write because they have LLMs, right? Well, the reality is in the new world, we're going to have these tools at our disposal, and we will still be expected to add value. We will still be expected to contribute. But you'll have this tool in your toolbox, just like today you have a calculator available to you. But that doesn't mean you don't take math class. But it means you calculate a cosine a whole lot faster.
Yeah, I don't need a pencil and
right.
Figured it out. Yeah, no, it's interesting. Yeah, Alexis, because we homeschool our kids. We have 3 teenagers right now, and we were actually having this conversation over the last few years because growing up, and being in school in the 80s and 90s, and it's like okay, graphing calculators all kind of coming on the scene, and I remember that conversation of like, oh, are you cheating by using these things? And it's like, no, that actually helped me when I also studied computer science in college. So it's like, I couldn't have I can't imagine taking those math classes without some of those tools. It would have been a lot slower. But then, recognizing that same thing with our kids, where it's like, okay, I don't want to keep them from this. I still need them, like you say, they need to learn to write and communicate. But I'd rather them learn to be really good with these tools and, like you're saying, add value. And it's a continually changing space, and it's like it's easy to be afraid of it, but it's also like, okay, how do I responsibly embrace it, but also recognize like, okay, there's some good things of like, okay, what do I not want it to become a crutch where they don't develop maybe some of those necessary competencies. So
in the old days in 3rd grade, they would teach people cursive.
Mm-hmm.
You need to be able to, and cursive is better than printing because I guess you don't have to raise the pencil as much, so you can do it a little quicker and blah, blah, blah. People need to be able to write letters because you need to be able to write letters because you'll spend your whole life writing letters. Well, nobody uses cursive, right? And because all of your communicating is really with your thumbs and Instagram. So we're
gonna have thumbing classes for our kids.
Exactly.
They don't need any classes. They figure that out pretty fast.
Exactly. So I think the point is, getting back to the data, the point is that it's the data that underlines all this, right? And so maybe if you think of data analytics, like traditional data analytics, it's it's a little bit like going from a calculator to a computer, right? It's a more fundamental stage, right? But I mean, that's actually the building blocks that AI is built on top of. And then I would also say for a company, like in many cases, you may not be aware of it, but it could be that when you go out in the future, that one of the most valuable assets your company has is that data set. And if you want to do AI, you're going to be doing AI on top of that data set. And and there's a lot of there are a lot of companies in the AI space, but what is truly valuable are proprietary data sets. But if you're not keeping that data or collecting it, then you may be one of your most valuable assets maybe slipping through your fingers.
That's a really good word. Yeah. Anything else like that you'd want to kind of, as we wrap up here, like that you'd want to just kind of at a high level or at a even more specific like that, say to the founder, the entrepreneur who's kind of anywhere along that journey?
I guess I would say just don't be afraid of it. I think it's important that you put those guardrails in place at the very beginning and you protect those, right? That contract, both the contract that you have with your customers as well as, for lack of a better term, with regulators.
Mhm.
financial or other type of regulators. And somebody said to me one time, well, who do you fear more, the hacker or the auditor? And I thought about that, and I thought, well, actually both of them, because the hacker can kill you quickly and the auditor can kill you slowly. So I'm actually afraid of both of them. But I think the point is, put the right frameworks in place, but then with those guardrails in place, and
Mhm.
then get into the game. And I think data is key to supercharging the business. I think it's also key to this world that we're moving into with AI, and
Mhm.
it will allow you to play in that space. And then, the tool stack, the tech stack will change over time. The processes will evolve. The people, you want the right people with the right perspective, and just be thoughtful about how you lay that out.
No, that's really good. No, I appreciate you taking the time to just share your wisdom and your experience in it. Even though the topic was on data, it's really apparent. Yeah, you have a whole ecosystem of expertise that allows you to not only understand what's going on with data, but the good stewardship of it, the application of it, how it relates to strategy and business, and bringing value to people. So definitely appreciate you sharing that with our community.
Yeah, and I think that's a key point, right? That your data strategy needs to be holistic.
Yeah.
You can't just look at it as the bits and the bytes, and what your data warehouse strategy
Mhm.
is, or your data lake.
Yeah. No, that's really good. Awesome.